So I'm Graham Elliott, but we'll get straight on with it, and Susan Walker is going to present her talk and she'll tell you what it's about. Go, Susan.
Thank you, Graham. I hope everyone can hear me. In this piece of work by Josh, Graham, Rochelle, and me, I'm just going to get it moving on. We're trying to understand how ship rate tracking rates, which are an index of rodent activity, are affected by aerial management and ecosystem productivity, different management regimes or control cycles, and we're interested in what this tells us, of course, about changes in ship rat populations. And the predictions are going to be an important input into the broad scale model to predict bird outcomes, which Dean and Adrian are going to talk about tomorrow. We use the national data set of overnight tracking. Now, this is mainly DOC, it's enormous, but acknowledging Greater Wellington's records up to August 2020, which was after the last great big mass that Joe talked about. Three things. First, the tracking network grew over time. We used the last 16 years. Second, we've got a lot more data for the South Island than the North. And third, we're going to talk about three types of forests today: pure beech, mixed beech, and podocarp broadleaf. These are the forest areas that those tracking data allow us to say something about. A key point is that forest type and temperature are not independent. So New Zealand's coldest forests are exclusively pure beech, and the warmest are podocarp broadleaf forests. And in this work, we divide pure beech into 6 classes here, from 5 to 11 degrees, a degree for each class. Mixed beech classes span 7 to 12, and 4 podocarp broadleaf classes, the fewest, 9 to 13. To analyze the data, we used the same basic method as in our earlier work. Patterns in time make characteristic shapes in these percentile graphs. When you see a median, this line here, all you need to know is that tracking rates are higher than this half of the time. So that work showed that as temperature increases, unmanaged shipwreck dynamics grade from eruptive. You get these characteristic J-shaped curves with low medians but high maxima in the yellow, green, and turquoise, to continuously ratty, high median tracking rates and high maxima, giving you that sort of toppled C. The boosted regression tree models we fit to the data and used for prediction include time, the year and month of sampling, so we're not putting any sort of mass predictions in here. They include environment, and temperature almost invariably comes out as the most critical factor, and aerial management, because the data span multiple 1080 operations, and hence these will have affected ship rat populations. And I guess the magic is that because the time since last aerial management operation is a predictor in the model, we don't need to throw data away. We can get at those underlying unmanaged rates simply by predicting once we would expect the effects of management to no longer be detectable, and we've used 7 years for that. And these are the results. The median unmanaged rates predicted by our recent models, shown quarterly from November 2005 to August 2020, each dot is a quarter, for 15 forest temperature classes, these legends down the right-hand side, and you can instantly see how ship rat tracking rates increase substantially with temperature within each of those 3 major forest types. In pure beech, we see the strong J shapes in colder classes, so these are peaky eruptive systems. That means in places like near treeline, like Alabaster, we seldom saw a ship rat over the last 16 years. They were at negligible levels 80 to 90% of the time. But down further near the valley floor, tracking rates are predicted to have been above 20% for over half that time period. So these are quite ratty forests as you get lower, even in what we would think of as cold forests. In New Zealand's mixed beech forest, there's just massive variation in ship rat tracking rates. With temperature, you can see this huge spread of median values for the different colours. Here's how that temperature gradient looks near Wellington, with cooler, higher mixed beech forests, about 5% median tracking, and they're behaving in that very eruptive way, very much like the pure beech forests. They often grade into near the tree line, but the warmest forests have median tracking rates right up near 50%. So that's the same pattern we see in large swathes of forest, say in Kahurangi, again, where they grade into the cool beech forests at the top, but are behaving very differently lower down. And here's the pattern for podocarp broadleaf forests, continuously ratty all the time, so 50 to 30% median tracking rates. Peaks and troughs are quite synchronous amongst pure beech and colder mixed beech, but in warm mixed beech there can be large fluctuations as those other species kick in, and in podocarp broadleaf forest, shiprat fluctuations do their own thing with timing. So one of the things that may be of concern and we're seeing is that rising population baseline of shiprats between masts. Dave talked about this, and this is seen really only in the pure beech forests that are the main refuges of species like mohua, kakariki, titipuna munau. And so this was the warmest mast in history. Here I've got the temperature anomaly data, and you can see this most recent intermast period was substantially warmer than any we've ever seen. So that's what's been happening without management. I'm going to move now to what happens after aerial management. The horizontal axis of these graphs is years since aerial management. It's not just time. So what we're looking at is our predictions of median tracking rates that would be recorded at different times after any aerial operation since 2005, taken as an average. So in all forest types, immediately after management, there's this big knockdown. Tracking rates go to 0 or very low, but then they increase in all of those forest types. And 2 to 3 years after an operation, we get this new maximum. And then things start to recede again. And you can see that they're much slower increases in the colder forests, much steeper increases in the warmer forests. Here on the right are the predicted unmanaged tracking rates that we can compare those to. So because most operations in beech forest follow a mast, the models always predict this initial decrease in the first year after management, the natural end of an eruption, and then you see some subsequent peaks, which are really showing that on average we get some sort of mast event around 3 to 4 year intervals. Don't worry about these peaks. This is the class where we've got the fewest examples, and so those are really skewing the data. But the key point is we can get to the difference that aerial management makes to rat tracking if we subtract this unmanaged rate on the right from the rate we would expect in managed forests. And here in these graphs, we've got that difference, the median difference in predicted tracking rate. Dots above the line mean that the tracking rates are higher in managed forests than in unmanaged forests, and below the line, they're lower. And these humps here in all of the forest types are the rat bounce. It's a period of time, 2 to 5 years after an aerial operation, that shiprat tracking rates become higher than they would have been in forests that were not managed. So these horizontal lines extend, I've just put them in to extend across the time periods of notable unders below and overs here above. And the thicker parts of those lines are showing us where those unders and overs are significant. So in all forests, the initial knockdown of shiprats is highly significant. In pure beech forest, when you get to the rat bounce, it's much later, it's briefer, and it's smaller than in these warmer forest types. There are no thick lines. In mixed beech forest, the cooler classes up near those pure beech tree lines behave a lot like pure beech forests, but the warmer classes don't. You get this bigger, longer rat bounce, which is as big and as serious as in the podocarp broadleaf forests. When we do the same analysis and the same predictions for mustelid tracking rates, which are probably largely stoats, we see that aerial management does a much better job on knocking stoat tracking rates down and keeping them down than on shiprats. So stoats also bounce here, they bounce hardly at all, and in all types of forest we get much longer periods of suppression for mustelids than we do for shiprats. Now there's a lot to look at in those graphs, and what I'm going to do now is just look at those two patterns side by side and say that it's reasonable for us to ask whether that rat bounce just reflects a behavioral change in the shiprats. So are shiprat populations necessarily larger, or are shiprats just more active and running around through tunnels more because stoats are away? After all, the rat bounces start to decrease and taper off about the time that the stoats start to get back to baseline or actually increase over that. So we think that higher rat activity in managed forests is part of the story, but probably a small part, not by any means the whole. To give an example, this is a mixed effects model fitted to data from mixed beech forests in 2019 with mean annual temperature along the bottom shiprat tracking on the vertical. These are estimates of shiprat tracking when no stoats were detected, and what we get between those lines is a rat bounce, just exactly what we would expect, because the operation that these relate to was 2 to 3 years earlier. So that's where we see the biggest the biggest rat bounce. When we put on a red dashed line that shows the fitted estimate for unmanaged forests where mustelids were detected, we might be seeing part of this may be greater shiprat, smaller shiprat activity, but also it may be an actual decrease in shiprat populations. The key point here is we don't remove the rat bounce altogether. We might exaggerate it, but it's still there. So we think the rat bounce and shiprat tracking rates is largely reflecting higher shiprat populations and not just more shiprat activity. And if that's so, we'd predict much better outcomes for birds of aerial management for larger bodied species like kaka, kia, kiwi, and whio than for smaller, more shiprat vulnerable species like mohua, robin, titipunamu, kakariki, bats. So many of these smaller species we know are already absent or rare in warmer forests because of that thermal squeeze that we've been talking about, but infrequent aerial management as a regime is not one that's likely to allow them back in or to sustain them, especially if those operations are far apart. So our models allow us to explore how a rat bounce plays out in the management scenario, and I'm going to finish up with that. The spring of the mast year operation scenarios I'm showing in these slides really did happen Te Akina na Manu, so they're strongly supported by actual tracking data. This is a scenario with just one operation in October 2014, got time over 7 years here, tracking rate up here, with the dotted line being the treated tracking rates, August, November, February, and May, and so on. Unmanaged rates are the grey lines behind, and you can see unders and overs through time. If you track along the dotted, comparing the dotted line with the grey, you first see the knockdown, the time when shiprats are much lower than in unmanaged forests, and then the lines swap over, and here we get the rat bounce. And then the lines converge again, and so you can see here, things have got back to normal. If we do a second operation in scenario 2 in October 2016, you see 2 unders, but you get an over that's delayed until the summer, autumn, and winter of the 2019 megamast. So here, much higher tracking rates as we wind up into that mast. And the only difference in scenario 3 with the third operation is you see us knocking the top off that biggest ever shiprat eruption. So the last thing I'm going to show is just how much temperature matters for those overs. When we look across the pure beech forest classes down this gradient, we see that overs in truly cold, simple beech forests are brief, they're small, they're of a magnitude. There's not much gap between these lines, so they may not be disastrous for our birds. It's a very different story down in the warmer pure beech forest classes, which could mean a disastrous breeding season for rat-sensitive bird and bat populations, or disastrous winter predation. It's the same story across our 5 mixed beech forest classes. As we get warmer, we have longer periods, bigger overs. So there are fewer data to run scenarios like this for podocarp broadleaf forests, but we can have very little doubt that the pattern of results would be similar. So the strong link between the rat bounce and the temperature send us to food as an explanation, that if we knock the top off a rodent eruption, we have this period when shiprat tracking rates are so much lower than they are in an unmanaged forest, and we're instantly removing possums too, and we're doing the same in podocarp broadleaf forest. That will leave a food bonanza that benefits shiprats down the track. So our conclusions. First, the tracking data are gold. So we've got the struggle to protect our birds, and these tracking data are our intelligence. We've got helicopters and traps, but peanut butter and pieces of paper are probably more important because we're up against this most successful of mammals, and we're going to have to devise better strategies and tactics as well as tools. We're going to need to know what rats are doing, and that things are changing fast as the climate warms. And as that climate warms, shiprats are going to benefit. Populations are going to get bigger, they're going to go up higher, and they're going to get further south in our forests. Ship rats are also going to benefit whenever and wherever we improve forest health and thereby increase food for birds. So we're just going to have to get smarter as we do that. And it's likely, not shown in this work, but as Dave's work certainly strongly suggests, that ship rat populations are also going to increase when we control stoats. Another conclusion is that the management challenge in our beech forests is far from solved. The idea that God will control ship rats between masts is just not a thing in warmer pure beech forests, and it's certainly not the case in mixed beech forests. These are perhaps our trickiest forests to manage, and the situation appears to be rapidly changing for the worst. What is clear is that for small-bodied bird species to benefit and for our forests to recover to health, we are going to need tools that control the full suite of predators. I've probably left time for a few of your questions. Thank you. Graham, you're muted.
Yep. Thank you. We've got a question from Doug, bless him, so I don't have to think of one. Susan says, Susan, could there also be competitive release from possums involved in the rat bounce?
Yes, yeah, definitely. I think it's all about food. I don't really think the ship rats care who gives to them, whether it's the death of their own whānau or the removal of possums. Yeah, so teasing that mechanism apart would be interesting, but I think, you know, it's the rats and the rat bounce we care about. So, yeah, I think that, yeah, it could be either, and it's probably both in warm forests.
No other question. Well, I can have one from me, Susan. What do you think it steers us towards doing? How would we handle, what are the hints about new management regimes we might want to deploy to get around these things?
I'm smiling because Josh is going to talk a bit about that next, and you are actually the expert, Graham. And so I think one of the things I see is around timing, because the rats are getting started in warmer forests so much earlier in a mast. It may be that operations in the spring are just not actually dealing with the damage that you're going to get through the winter. And I think, yep, it's timing, combinations, and so on that are going to need to shift. And I think I can see a big experiment coming on, really, that we're just going to need to try a whole lot of stuff, because this is about getting the least worst outcome. The worst outcome would be just letting it happen for our birds. And so I think it's, for me, this is a real problem. It is a real struggle, but we're just going to have to outwit them somehow.
Thanks, Susan.